9 months old, still chewing things it shouldn't, still occasionally trips over its own paws, already old enough to have puppies of its own. That's the first problem with the rule everyone uses. Multiply by 7 and 9 months becomes roughly 5 years old in human terms. No 5-year-old is reproducing. The formula breaks before you even finish testing it. But where the rule actually falls apart is stranger than bad arithmetic. In 2020, scientists looked at what's actually happening inside a dog's body as it ages, at the molecular level, and found that most dog owners have been miscalculating their dog's biological age by decades. Nobody knows exactly where the 7 times rule originated. The oldest recorded attempt to compare dog and human lifespan is carved into the floor of Westminster Abbey, the Cosmati pavement, installed in 1268, which put the ratio at 9:1. By the 1950s, that had shifted to 7, most likely because of the simplest arithmetic imaginable. Average American lifespan at the time, around 70 years. Average dog lifespan, around 10. 70 divided by 10. No study, no veterinary consensus, just division. William Fortney, a veterinarian at Kansas State University, gave his honest read when asked about it. He suspected the whole thing was a marketing device to get owners bringing their dogs in at least once a year. Whether that's true or not, the rule has been repeated for over 70 years, on the basis of a calculation that took about 4 seconds to invent. The 7 times rule assumes dog aging is linear. 1 dog year always equals 7 human years, at every life stage, without exception. A 7-month-old dog, sexually mature, capable of reproducing, would be 4 years old under the formula. A 4-year-old child, an 11-year-old dog, slowing visibly, sleeping longer, showing age in its joints and face, would be 77, but its body has been through the biological equivalent of nearly a complete human lifetime. 77 understates that substantially. The ratio isn't just imprecise, it doesn't correspond to anything real about how dogs age. In 2020, Trey Ideker and Tina Wang at UC San Diego approached the question the way aging researchers actually study it, through DNA. As both dogs and humans age, small chemical tags called methyl groups attach to specific locations on the genome. The pattern changes in measurable, consistent ways as cells accumulate age. Read the pattern accurately, and you can estimate biological age with surprising precision. Scientists call it the epigenetic clock, the molecular record of everything a body has been through, written directly into its DNA. Ideker's team pulled blood samples from 104 Labrador retrievers ranging from 4 weeks to 16 years old, sequenced their genomes, and mapped the methylation patterns against published data from 320 humans spanning ages 1 to 103. The collaboration involved the National Human Genome Research Institute, UC Davis, and the University of Pittsburgh School of Medicine. The study was published in the journal Cell Systems. The result was not a straight line. It was a steep curve early on that flattened substantially over time. Dogs don't age at a consistent rate. They burn through biological age at a speed that's hard to square with how young a 1-year-old dog looks, then slow considerably. Human age equals 16 times the natural logarithm of the dog's age, plus 31. 1-year-old, 31 human years. 2 years old, 42. 4 years, 53. 7 years, 62. 10 years, 68. 12 years, 70. That last number was flagged by the researchers specifically. 70 years is the average worldwide human life expectancy. A Labrador retriever that reaches 12 has traveled the biological equivalent of a full human lifetime. After the study was published, Ideker said something about his own 6-year-old dog. She still ran with him. But, and this is the researcher who built the formula, who spent years with these numbers. I'm now realizing she's not as young as I thought she was. He built it. It still caught him off guard. If this is landing differently than you expected, hit subscribe. We cover the real science behind your animals every single week on The Pet Theory. Now there's a major caveat to these numbers that changes them depending on what dog you have. The formula was built entirely on Labrador retrievers, and size changes the numbers considerably. A Chihuahua lives, on average, 15 to 17 years. A Great Dane lives 7 to 10. Same species. The lifespan gap between them is larger than the difference between a healthy human and someone managing serious chronic illness. The leading explanation involves growth rate. A Great Dane puppy goes from a few pounds at birth to over 100 pounds in under a year. That pace of cellular division accumulates DNA damage faster, compounding over time. Larger breeds also die of cancer at significantly higher rates. A University of Adelaide study across 164 breeds found that as average body weight increased, so did the likelihood of dying from cancer at a younger age. A University of Washington study tracking 169,000 dogs put a specific number on it. For every 4.4 pounds of body weight, a dog loses roughly 1 month of life expectancy. A 6-year-old Great Dane is already a senior animal. A 6-year-old Chihuahua is middle-aged. Same calendar year, entirely different biology. The 7 times rule didn't just give dog owners wrong numbers. It gave them a wrong sense of time. A 3-year-old dog isn't 21 in any meaningful biological sense. Its DNA has already undergone the equivalent of roughly 5 decades of human aging. If you've been thinking of a 3-year-old dog as young, you might have delayed a screening that didn't feel urgent yet. You might assume you have more time than you do to catch something early. The window where detection changes the outcome is open now. Not at some future point when the dog starts looking old. It's why veterinarians recommend senior wellness panels, starting around age 7. Not because 7-year-old dogs are ancient, but because of everything that has already happened in those years. More frequent checkups earlier isn't overreacting. It's the correct response to how dogs actually age. The curve also shows something worth holding on to. The compression is front-loaded. Going from year 1 to year 2 costs 11 biological years. Going from year 7 to year 10 costs 6. Year 10 to year 12 costs 2. The later years slow considerably. A dog at 10, 11, 12 isn't burning through time the way a 1 or 2-year-old was. Those years are biologically quieter, more present, lived at a pace that finally starts to resemble your own, 1 year closer to 1 year for the first time. The formula made us underestimate how fast our dogs age when they're young. It also made us underestimate how much the later years actually contain. A 2-year-old dog isn't a teenager. They're in their 40s. A 10-year-old isn't ancient. They're in their late 60s, with real years still ahead, living them at a pace that finally starts to resemble yours. The number isn't there to make you grieve. It's there so you know where you actually are. And with something you love, accurate is worth more than comfortable. How old is your dog, and what does the real formula make them? Drop it in the comments. I want to see the numbers. Subscribe to The Pet Theory, and I'll see you in the next one.